Okay, so let's have a look at this question. This is related to quadratic modelling. Luke is marketing a new brand of dance shoes. He's chosen a mathematical model which shows how he expects the average weekly profit made from the sale of shoes to vary depending on the price of shoes. Luke's model is given by the equation of that, and I've got a quadratic in terms of x, where x is the selling price of a pair of shoes and p is the profit. Actually, it doesn't say that, but I think that's what it means. Oh yes, we can infer that from the graph. The graph of this function is shown below. So I've got p here, I've got x here, and I've got this curve. So as the price of the shoes varies, the profit that we make from those shoes also varies. Okay, so the first question says, how much profit will Luke make if he sells shoes for £135? So what we've got here is that our x is going to be £135, and I want to know the value of p at whatever point it is at that particular point. I'm not sure where it is on the graph. Okay, so let's have a look at that. So at x is that p equals minus 2 times 135 squared plus 324 times 135 minus 7081, and I'm going to type that into the calculator exactly like that. So I'm going to type in exactly as I see it there. Let's just delete all of that, just get rid of it all. Okay, so there we go. So I've got minus 2 times 135 squared plus 324 times 135 minus 7081. Okay, and the answer is 209. So remembering to put the units in the final answer. So the profit is £209. Okay, Luke is aiming for profit of £5,000. What selling price should he set? So this time, the profit is 5,000. So P equals 5,000, not X. So at P equals 5,000, I have minus 2x squared plus 324x minus 7081 equals 5,000. Always write that down before you do any simplification or balancing, because you'll be picking up marks for that in an exam. So I've got minus 2x squared plus 324x minus 12081 equals 0. At that point we don't need to do any calculation, we just stick it in our calculator, which is polynomial degree 2. As you can see, I've done this before, haven't I? So I've got minus 2, 324, and that one needs to be minus 12081, and we press solve, and I get x equals £103.81, or x equals £58.19. Either of those values would give you a profit of 5,000. So one will be at this side of the minimum of the maximum, and one will be at this side of the maximum. So one will be over here somewhere, and one will be over here somewhere. Okay. So next part, what is the maximum selling price that Luke can set and still make a profit? Okay, so what I'm after here, so this is my unit price changing. So what I am after is sort of over here as exchange. I'm making a profit here, I'm making a profit here. Here is the point where I stop making a profit. So anything less than this value, I am going to make a profit. Anything more than this value, I am going to make a loss. according to this model. So what I want to do is to set my profit, let's make that explicit, at p equals 0 minus 2x squared plus 324x minus 7081 equals 0. Okay, so that is what I'm going to solve on my calculator. So this time it's exactly the same, minus 2, 324, and then in there we have minus 7081, and I solve that, and I've got two solutions. So I've got x equals 1. I'm going to write down the solutions of these first. So I've got 103595. I suppose there's a little subtlety here. I'm just going to go to 3 decimal places on this one, and this one I've got x equals 26.041 to 3 decimal places. Now if we just look at this now obviously this is the one that I want, because this is the highest profit, isn't it? It's the maximum selling price that Luke can still make a profit. And if the question is, do I want 135.96 or 135.95? Now can you see if I went 135.96, it would just dip into loss, tiny little loss. So the answer is 135.95. okay, and that will just give me a tiny profit. Okay, what selling price should Luke set to maximize his profit? Okay, so what I'm after this time is this value here, this point here, and I'm after that value of x there. And what I'm going to do on this one is I'm going to simply graph it. I'm going to use my calculator on this one, because I think that's the sensible thing to do in this case. So I'm going to actually graph minus 2x squared, well, the original equation, minus 2x squared plus 324x minus 7081. I'm going to draw it. You may not see something that looks exactly, that shade. You might only see a tiny little part. There's various things you can do. You can set the V window. Zoom and auto is quite a good one that often makes it quite useful. And if you want to kind of move the graph around, use the cursor, and it's just centralizing it to make it look nice, and so that it's, the bit that I want is in the middle. Right, okay, so G-solve max, and I have got a maximum point of 81,604,1. Those are the coordinates of my maximum point. So the selling price that I need to set is going to be £81. So if I set a selling price of £81, I will get a profit of 6,041. That's what that is telling me, because that is that point there, 81,604,1. Okay, you can I think on that, I think using your calculator would be a very appropriate way forward. Okay, so finally we have this kind of understanding question. Do you think Luke's choice of a quadratic model is sensible? And I think this is this is a difficult one, isn't it? Because it just takes a little bit of common sense and sort of understanding. Now suppose if we're buying some shoes for a certain value, and we sell them for a different value, so this is our kind of selling price. Now if we were to sell if we were to set a very high unit price, I think probably the upshot is that we're just going to sell less of them. So our profit is not going to go is not going to go negative. It's not going to go negative. It's just going to, it'll just mean that we won't sell any, so our profit will tend to zero. Because, so what I'm going to say is that no, if we set the selling price too high, then we will sell very few, so the profit will tend towards zero as X increases. So I think the more likely sort of graph is that as X gets higher, it's going to go sort of off like that. So I think we could be saying something like that as X is higher, then a quadratic model is probably not going to be an appropriate model. Okay.